Hi, this is Matt Heffernan. Welcome back to my channel. If you aren't a subscriber already, please go ahead and do so, and then you can go and see all the videos that I've been doing so far. And what I'm working on right now is this series for the XCI adventure game engine that I've created for the Commander X16 retrocomputer. And in the previous episode of this series, I went over some of the basics about how to do animation. And of course, that's any graphical adventure game. The animation is going to be the big part of it, and in terms of what the user is going to see and experience the game and so forth. And in this episode, I'm going to concentrate more on the actual traditional animation concepts, and that is sprite animation. The Commander X16 gives you the ability to have these sprites that can be freely moved about the screen, and we're going to show you how XCI allows you to exploit that feature. So, for XCI sprites, what you get are 16 by 16 pixel sprites. So if you need to have a sprite that's bigger than that, you're going to have to sort of group your sprites together. But for the purpose of this tutorial, we're just going to show each figure that we're animating is only going to take up a single sprite unto itself. And we're going to use the very basic type of sprite that you could imagine in terms of the classical animated figure, and that is a bouncing ball. And using the honored tradition of squash and stretch. So, what we're seeing here in this first slide are basically the three states that we're going to have for a bouncing ball. Now, frame 6, if we've seen some of the previous videos, we've defined a bunch of sprites already and gotten into a little bit of how we animate them. We're going to talk a little more in depth about some of the concepts and do a more sophisticated animation here. So we're going to actually have real animated frames for something. And for a ball, obviously most of the time it's perfectly round. It's flying through space, it's nice and round. But when it hits a surface, if a ball is going to bounce back, that ball is going to be distorted. So if it's hitting a horizontal surface, it's going to squash horizontally, like here in frame 7. And then it's going to rebound, go back to its original shape, but it's going to overcompensate and actually stretch out a bit. And that's how we would get 8. So what we would see if we were bouncing off the floor or the ceiling, we would come in with frame 6 in the normal state. It would squash against the floor or ceiling to stretch out a 7, rebound back to shape 6, and then hyperextend into frame 8 and before again returning to 6, and that gives us more of a realistic look of how a ball would bounce off a floor or ceiling. Now the nice thing is we can since we're dealing with a very constrained system here, for XCI you only get so many different frames available to you, and you have to use those for the whole game. If we go back and look at the documentation, we can see here I've already moved to the part of this README file where I talk about the different keys that you can use in a level file, and we're going to talk about the sprite ones and specifically here, the Sprite Frames, Sprite Hide, and Sprite Move. But we're going to go back a bit here to the beginning and we'll see how things are laid out. And in terms of sprites, and we've talked about this in previous videos, but you have 499 unique sprite frames, and that's what you get for the whole game. No matter how many levels or zones that you define, you only get those 499. So you got to make them count. And of course, your mouse cursors count as your sprite frames, so you're automatically losing those. So again, I'll go back to under here in the README, under level files and keys, we can see here the different instructions, and this is a nice look into how we actually use in context these different instructions. And of course, in the syntax documentation, you get a more formal layout of all the different arguments that are used for each of these instructions and providing range and context for more of a quick lookup, if you will. But here we're going to talk a bit about them. And again, we've seen some of these in previous videos. So how do we actually use these instructions to do these animated sequences? We got to fly it around using frame 6. We got to do this pattern when we're bouncing off a floor or ceiling. When we are doing this sequence, when we hit a floor or ceiling, when we hit frame 7, this squashing horizontally, we actually have to change the Y direction because it's really bouncing at that moment. So it's going down say if it's bouncing off the floor, it's going down at 6, it's hitting the floor at 7, and then it starts going up at the next frame 6 through that 8 and then a 6 again. So here it's going up. Same thing here with a wall bounce. So say if we were bouncing off the right wall, we are at frame 6 still going to the right. At frame 8, we are actually hitting that wall and then changing direction, and then the rest of these frames are going to actually start going left. So how do we actually do that? Well, let's take a look at the instructions that are available to us. So for sprites, you have 4 different instructions, and that's pretty much all you need to be able to do whatever you need to do with a sprite. Oh my goodness, how did these not get fixed? Oh boy, look at this. This is fun. This is how this is used. We're gonna get rid of these labels. I don't know. These labels were gone, and then they came back. So if you've been watching my videos, you've seen me use some of this tool set before. This is, of course, LibreOffice. I am very much an advocate of open source technology, especially for software. And all of the things that I'm doing for the Commander X16 are open source. I do not have any sort of copyright protection for this. It is all out there. I put a strict copyleft decorations, if you will, on everything I do. It's nothing really legally binding, but I do have the GPL license, so that if somebody's going to use the engine, they're complying to the terms of that license. Anyway, that's a bit of a tangent. So what we can see here, this little bugger, all right, just fine. We'll leave it at that. I'll fix it later, because all these frames, I'm sorry, all these slides are available in the GitHub repository. There's going to be a link in the description for that, and you'll be able to see all of these slides. And there's a tutorial guide that's also up there on GitHub, and it'll help you be able to sort of go through this tutorial in more detail at your own pace and have it better make sense for you. So anyway, back to these instructions. Sprite frames. This is what we define a sequence of frames, and these sequences will repeat if you go through them, as we'll see here. Here we're defining a sequence of 4 frames that we're going through. We see the round one, we see the horizontally squished, and then the vertically squished with another perfectly round one in the middle. So that is how we would use sprite frames. We set what the current frame is. That's going to be the first one in the sequence. And then in the future frames. So here it's going to go through this sequence over and over again. And then there's the sprite instruction, just sprite. And that's how we set the current position and then render that sprite. So we're giving it an X and Y value. That will be the upper left corner as shown here. And that's the specific position on the screen where you're going to place it. And that is an absolute position. It's not relative to the particular view that you're doing. So that if you're putting a sprite in a title screen sequence or in a level, it's the actual XY is the XY for that screen. And we're talking about a 320 by 240 screen. And you only get a subset of that for the levels. And that's something to keep in mind, where you're talking about a 320 by 200 level area, graphical area. You have to deal with the first 8 pixels at the top, those 8 rows of pixels, that's the menu bar, and then you have the next 200 below that are where your sprites should be placed. You could hack the system and put them wherever you want, but in general practice, you're going to want to keep them in that area. And of course, you could go below, and then you're putting sprites over where the text area and the toolbar is supposed to be, and it will just kind of look weird. So just try to make sure that when you're doing these instructions that you're setting the sprites within the position where they'll be sitting on top of the background of your level, or obviously the title screen, and that then when you do a sprite move instruction where you're setting the future positions and the frame rate, that once you get to the end of that sprite move sequence, that your sprite will still be on screen. And so basically, the sprite move, we are defining the future positions so that we have the initial position was defined by the last sprite command, or perhaps wherever we were in the previous sprite move. And then we will start with whatever the current sprite frames are. The first frame will be where we put it, and then we'll have these these vectors of x and y, that each successive frame, animation frame that is, we are going to move the sprite by those amounts. And here we can see this difference in x and y. And actually, boy, I really messed these up because these should have been a lot bigger. So what we're talking about is not sort of this difference in x and y. Ooh. We're talking about a much wider difference, where we're talking from here to here is your delta x. So look at this. Here we're making things actually make sense in real time, right? And we're getting rid of that stupid quote, because that doesn't need to be there, right? So this is your total delta x from here to here, so that you're really making a big change. And then the same thing goes but with the y, this is actually accurate here, where the y is changing by a much smaller amount than the x position. And then we're also talking about the time, so that within the sprite move, which we will see here in the syntax for sprite move, we have a delay. And then that delay is a number of jiffies. As we've talked before, jiffies are 60 to a second. So we have a pretty fine amount of granularity. And we can say that it's this many jiffies to go from one frame to the next. And so with each of those delays between frames, we will move that sprite by this XY vector. And then finally, just simple sprite hide, where we say, all right, we're just going to disable the rendering of the sprite, so it could still be moving or whatever. Doesn't matter. We're just going to hide it. And another important caveat to remember is not only will the sprite hide is not the only way to disable a sprite. Effectively, if you do a new sprite frames in the middle of a sprite move, it's going to mess everything up, and you're not going to be able to see what's happening anymore with that sprite, because the sprite move has to be initialized by that sprite frames before it happens. And when sprite frames happens after it, then the whole scheduling of that sprite movement gets messed up. So generally what you want to do is do a sprite frames, and then you do a sprite move. And you could do multiple sprite moves after that if that same frame sequence holds. And as we can see here, that this 4-frame sequence, here we're doing a movement where we're going through all 4 of those, and then we're starting again from the beginning. So we can see here we go back to the round one and then the wide one. And presumably if we did more than 6 steps within the sprite move, we would see more than that. And that's it. That's all it takes to define how sprites move. Obviously, they're going to get tied in to things like triggers and states and whatnot. But when it comes to the actual rendering and movement of those sprites, this is what you have. So let's take a look at the template that we had started modifying for this tutorial series. If you went back to a previous episode, you would have seen here the very initial level of the game, all we did was say print hello world within the text field, wait a couple seconds, and then automatically go to the next level. So let's just, for our basic purposes, we're going to build the game and run it. And there's that title screen. And then when we do file new, we're going to see that hello world, 1 a second, 2 a second, and then we're at the next level here where when we did things with inventory. If you go back and watch that inventory video, you'll see how we created this level. But we don't care about going to this level automatically. What we want to do is have a little bouncing ball happen in the previous level, and just be able to sit and appreciate that, and not automatically move on. So first things first, we're going to start getting rid of some of the stuff. We don't want to have this 2-second wait anymore. We're not going to do that. And we're not going to do the automatic go level in that sequence, but we don't want to get rid of it, so we're just going to comment it out for now. We have some plans to do something with that later. But what we do want to do is actually start rendering that bouncy ball. So what we want to do is sort of place it right in the middle of our display. As you saw when we just played it, there is no background, so we don't have to really align the sprite to any particular bitmap that's laying behind it, which is the normal case of what you'd have to do. But for simplicity's purposes, we're going to just place it pretty much in the middle. And of course, since it's in the middle, it's not hitting any imaginary walls or ceilings or anything like that. So what we're going to do is we'll go back here and say, yep, okay, we have these three. So we need to define these three sprites to be available for us. So as we've seen before, we have this spreadsheet. And here I've already gone to the trouble of creating these three frames. So again, they're 16 by 16. They're just using a couple different colors here. If we go down here, we can see another instance of our palette where the darker red is 2 and the lighter red is A. And that's all there is to it. They're pretty similar. So then we go and look at our sprites. So let's sort of backtrack a bit. And we said here our sprites are in sprites.hex, and here's sprites.hex. And here we've done, if you can see here, that frame 5 was the grail that we had defined in the previous episode. And now here's frame 6. Here we see that round ball. It's kind of easy to see the 2s against the 0s here. And here is a wider ball, and here's the taller ball. And that's it, frames 6, 7, and 8. So we want to just initially want to move that ball through the field of the level, just the basic roundness. And so what we're going to say is our sprite frames for Sprite 1, we're going to use Sprite 1 as that. Now, as you see in previous videos, the Sprite Frame 0 is the mouse cursor. That's reserved. So our Sprite frames, our actual Sprite index has to be from 1 to 127. Because the Commander X16 gives us only 128 different sprite indices to work with, and it reserves that sprite index 0. So 1 through 127, those 127 sprite indices that we have to deal with at any given time, since we're using a mouse in this with this engine, and you're forced to use a mouse. So that's what you're going to get, is 127 different sprites moving across the frame plus the mouse cursor. So we're going to say that this ball is going to be sprite 1, and we're going to use palette offset 0, so it's that standard palette that we saw in the spreadsheet before, and we're just going to use 6, frame 6. So it'll just always look like frame 6, and what we're going to want to do is just go ahead and place it. And we're saying we're going to place sprite 1 at 152x and 100y. So what does that actually do? Let's go ahead and build with the SDK, and then we'll run it in the emulator. And we'll say, here's a new game. And there it is. And now we can see the ball, and we don't have that 2-second timeout. It'll just stay here as long as we want. And there it is, pretty much in the middle. So we can see here is the menu bar, and we're about halfway down from the menu bar and halfway up from here, the text field. Here's the top of the text field, so we're pretty much right in the middle here. And you notice we gave it that 152, 100, and that gives us, that's really this point right here, not the center, as you recall. So this, by shifting the center up 8 to the left and 8 up, that gives us a nicely centered sprite right there. But that's not too interesting. We want to actually move it. So let's go back here. And now we do a sprite move. You're moving sprite 1. We want to do 10 frames a second. So, you know, not too bad. Or actually, I'm sorry, not 10 frames. We're going to do, we'll do 15 frames a second. So in order, or rather 20 frames a second. So I can't keep track either. So we're dividing a second up into jiffies. And so there's 60 jiffies a second. So if I say 3, then that means, all right, we're going to be doing 20 frames a second. And so every 3 jiffies for 23 steps. So that means over a period of 69 jiffies, we're going to be just moving the sprite. The x vector, part of the vector, is going to be 0, so it's going to be not moving at all horizontally, but then the y is going to be 4, so it means it's moving down 4 pixels. And that's what it's going to do. It's going to just 23 times is going to move down 4 pixels and do that every 3 jiffies, so 20 frames a second. So again, we'll build. We see that little thing again. And then we do a new game, and there it is. And now it's down close to the bottom, not quite the bottom of the level. So what we know is that at this point we are very close, but he's not going to be, the actual floor of the level is down here. You can see like at the top of this exclamation point. So we've got a few more pixels to go. So what we're going to do is once we get past the end of this move, which we're going to say, again, so that was 69 jiffies. So we're going to do a wait of 72. So that will be all of those, that entire movement plus another 3 jiffies, so that we know we've gotten to the end of the sequence, and then we're ready to make a new movement. So what we're going to do is say here at the end of that 72 frames, the 72 jiffies, we're going to set up a new frame sequence. And we're going to do, oops, let's get that correct. And we're going to say we're going to take frame 1, and then we're going to, again, we're not changing the palette offset. We're staying at 0. And then we're going to do 7, then 6, then 8. And that gives us, as you recall, this part of the sequence. So we've been going down with 6, and then we're going to continue We're going to hit bottom at 7, and then rebound with a 6, and then an 8. And then we're going to do 6s later, but here we're just doing these 3 frames. And we're going to say now we're going to set a new position for the sprite. So this is effectively like the 4th step of, or the 24th step of moving down from before. But by changing, oh, SP tight is not a word. By changing the first frame to 7, it's going to be squashed. And we're going to say now down at 152, 196. So what that does is it moves the sprite. It actually starts moving the bottom past the bottom of the level area, giving us 4 pixels underneath. And we can see here in this squashed version of the sprite, we have these 4 rows of transparent pixels underneath it. So we want to get this bottom edge of the actual visible part of the sprite right at the bottom of the screen, and that's what this Y value of 196 will give us. And then we're going to start moving back up in the opposite direction. So we're going to do a Sprite Move of 1 in the sprite, index 1. Again, every 3 jiffies, we're going to go 4 frames. And what that will allow us to do is go up basically 4 clicks, and it'll continue to move that sprite, and we'll be able to sort of stop it at the end. Actually, you know what? Well, let's see what this actually looks like, because I think what because we're not going to stop it right away. But here you notice we're doing a x of 0 again, and now a y of -4. So we're moving up. So let's see what that looks like. Oop. What did I miss here? Oh, I forgot to say yes. Of course, we're talking about sprite 1 is going to be at 152, 196. So now, oh, you see, and it's gone back to flat. So we don't want all 4. We just want 3. And so I noticed that is a little no-no there. I didn't want that. So what I want to do is return it back to 6. Give it that extra sprite frame so that we don't hit that 7 again. And then we'll see here when we go back and run it, it's hitting the bottom, and then, yeah, it's reconstituting back to where it's supposed to be. So we're going to then go ahead, and now we don't want to keep cycling through all of these. So here we're going to say, here, after these 12 frames after that happens, we're going to go ahead and again revert back to this just sprite frame 6 all the time, and then start doing a move using this same sort of vector, but instead of only going 4, we're going to go 43. And keep moving up almost to the top of the screen. And let's take a look at what that looks like. Oh, let me... So you can see it bounces down, comes back up, and almost to the top of the screen. So there we can see some of the basics in there. Now, what I'm going to do is sort of fast forward a bit, if you will. What I'm going to do through the power of Git is go ahead and discard these changes and It's like the magic of TV. Now I've gone and pulled the full version, but we're going to go back and make some of these changes. Like here, I knew that this wants to go back to 6, and I have other cases here where it's like, yeah, I think I may be wobbling a bit. So we're just going to go ahead and add 6s everywhere we can at the ends of these little bouncy sequences. All right. So let's go ahead and run this again. We're going to rebuild it. And before we actually play it, let's take a look at what the rest of this is doing. So once what we had done before was these 43 steps going all the way back up to the top. And then here we're going to do that 7686 again. And that's bouncing this time off the ceiling. And then we're going to start moving. Instead of coming straight back down with that sequence, we're going to start moving this 3-3 vector, which means we're going to down to the right by 3 and down by 3 with each frame. So it's going to be going in a nice 45-degree bounce. We're not really obeying physics here. These sprite moves don't allow you to do parabolic curves or anything. It doesn't have that sort of math built into it. This is a very simple game engine. So that if you did want to do sort of a parabolic curve, you're going to have to sort of break that up into straight line segments, and just do your best. Basically, just do your best. So that's what we're going to do. Is we're just going to sort of fake it until we make it hit again this wall, and then we're going to do that sequence here. You know, so we're very specifically setting all these wait times so that we get to the end of that move, and we're waiting, and then when we get to the end of that, then we're changing the frames, because we don't want to mess up this move while it's in the middle. And other things can happen during your sequence, like you could be moving this frame, this sprite, and then in between that, you could be doing a whole bunch of other stuff within the game. So you don't have to just wait till the end of it to do something. You can wait like through part of it and then do something else. But here we're just dealing with the one sprite, and we're not, plastering up a bunch of tiles or anything. So here we can see we're doing this. We're doing 3-3 until we're going down 45 like my mouse cursor here, and then we're going to hit that right wall. And when we hit that right wall, we're going to do this sequence, that wall sequence that we'd seen before on the slides, and then we're going to start changing our direction here to do a -4x and 0y. So that means we're going straight to the left, and we're going to go all the way across. So we're gonna do this little bit of the sequence where we're rebounding the ball, and then we're going back to a fixed 6 frame where the ball is just perfectly round, going all the way across the screen, 73 steps, and that's going to take 219 jiffies. It's going to take a couple seconds to go through, and then again, we're doing the same sprite frame sequence as before, the 8676, but now it's going to happen off the left wall, and so then our move vector is a +4 in the x direction. And so we're going to do that, and then we're going to wait 12, we're going to go back to 6, and what we're going to do is then after that start sloping down. So we're going to sort of try to do, like I said, we can't do a true parabolic arc, but I can come out straight and then do a diagonal down. And that's as close as we're going to get. So we're going to, once the ball's reconstituted, start going down diagonally, again, that 3x3 vector. And then once it hits the floor, I'm going to do that same squash, that horizontal squash, and then set that sprite position right there. And now here, I'm not doing a move. I am just doing a single frame where I'm saying, here, I'm waiting to the end of this sequence, plus another frame, because here you see it's 3 times 11, 33, so I'm waiting 36, and then just saying, all right, one frame of 7, and just moving that, and then waiting the 3 jiffies to then start doing a move with frame 6. So it's hitting the floor, reconstituting, but then staying on the floor. So you can see here I move it up a pixel for that ball to reconstitute itself. And then I start moving it, basically rolling it across the floor. So here I am moving it 10 frames, doing 3 to the x at a time. You notice now this is a little slower than it was flying through the air. So we're sort of mimicking friction at that point by slowing it down. And here you can see the friction taking place. So 10 frames going 3 pixels at a time, then 5 frames, 2 pixels at a time, then another 5 frames of only going 1 pixel at a time, and then finally coming to a stop. And then you'll notice here I did a little tool trigger. And I moved that go level. It's no longer commented out. I put it within the context of a tool trigger. And you'll notice here I have some these tile coordinates. And this is roughly, these are 4 tiles that roughly correspond to the final resting place of that sprite. So that then once it goes through this full animation sequence, we'll hit the end anim of that. And what will actually happen is for those even before this move finishes, those last 15 jiffies, that gives us basically just enough time to move the mouse cursor over to it and go ahead and click on it. So this could actually still be moving when this tool trigger happens, and that's fine. It's close enough for government work, as we like to say. So let me go ahead and did I rebuild it already? Yeah, I think I did. Anyway, so now let's take a look at what our little bouncing ball looks like. So we're bouncing against the floor, going up to the ceiling. We're going now diagonally left wall, and then magically going straight again. And then here's our little fake parabola. And we've come to a stop. And now we move the mouse cursor. Hey, look, there's our little use cursor. And we can click on that, and that takes us then to the next level. So that's it. That's the basics of how you do sprite animation. So, of course, you can go back through and watch this video. I'll be, posting all of this code that you can sort of go through, but it's more or less self-explanatory. If you go back and read the documentation, and the main thing is for you to go and play around with this stuff. And let's face it, right now we've got lots of time for playing around with this stuff. So play around with designing your own sprites. Play around with doing sprite instructions. Just play around with the Commander X16, which is now available as an emulator for free. And also for free is XCI, where you can just start messing around. So you don't have to jump right into learning all these basic commands or even perhaps more intimidating assembly language. I've done all of that stuff for you so that you can go ahead and get some of the fun stuff going on. In fact, look at this. You'll even get to see, hey, I actually saw the part of the video where he fixed all of these little formatting issues. Yes, you did. So that's what you're going to be able to have access to during this time, which is, it's very hard. A lot of us are out of work or just working from home, not getting a chance to have a lot of human interaction, and probably spending a lot of time just sitting home watching TV. But you could really spend this time productively and start to learn something new, learn how to do animation. You don't have to go to art school to do this. I never went to art school. I'm an engineer by trade, and I certainly in my education never dealt with any of this stuff. Just learned enough to be able to have the tools to be able to do it. And so I hope that you spend this time where we're kind of cooped up to be able to create something new. And then when you look back on this time, rather than being, oh, I'm just depressed, I was doing nothing, I was watching TV, I actually created something. And then I went ahead and shared it with the world, which is what I hope you also do. So again, I thank you. If you haven't already, please go and subscribe to my channel. Go back and watch the rest of this series or some of my other demo videos that I have up on YouTube. You can click the bell to be notified of when the next episode of this or any of the other videos that I post come out. And I'll see you next time. All right? Thanks. Bye-bye.